So, in order to understand the derailment theory or track parameters, you have to understand first what is the rail-wheel interaction. So here the two words are important. So one is called rail. Rail is important as well as wheel is important, because over the rail only our wheel will move. Over the rail our wheel will move. So whenever over the rail wheel is moving, so what it will do over the rail. So in order to understand this, so then you can go for track parameters, means it will be easy to understand what are the important parameters that will influence the derailment. So those things and all will be known to you if you are able to understand these two. That is rail wheel interaction if you are able to understand. So then track parameters also automatically you can understand easily. So that's why, so first few minutes I will take a class on rail wheel interaction. So then we'll go for track parameters. It's clear? It's clear why I am telling you rail wheel interaction for you? Okay, right. So rail and wheel both are important. Suppose if you see here, so rail is there as well as wheel is also there. So for any derailment, the problem may be with the rail also, the problem may be with the wheel also, both are possible. Or any one. Suppose a wheel is having a problem, rail may not be having a problem. Or rail is only having a problem, wheel may not be having a problem. So that is why we have to combinedly learn both the things, minimum things first. So then only you can understand better about track parameters. So that's why I wanted to cover to you both the track parameters as well as rail basics. Okay. So wheel basics only I will go. I'm not going deeply about wheel because wheel daily you're all JE workshop, JE diesel, JE CNW or any persons means you may be daily watching the wheels. So rails only the mechanical people will be having a lack of knowledge on rail. So that's why rail is very important. Then similarly wheel is also important. So whenever you see the rail cross section will be like this. Are you able to see the rail cross section, all of you? Rail cross section are able to understand? Okay. So now, first and foremost, you have to understand what is rail, what are the names used in the case of rail, how many types of rails are available. These things are very, very important. Now, the picture in the PowerPoint I am showing you, this is 52 kg rail. Actually, you may puzzle that what is 52 kg? Then any other type is there or not? That also you will get it out. So in Indian Railways, we will see the variety of rails. So for meter gauge separate rail, narrow gauge separate rail, broad gauge separate rails. So I am talking about in this class about broad gauge rails only. So in broad gauge rails, there are 52 kg rail, one is. Another is called 60 kg rail. Another is called 60 kg rail modified. There are three varieties are coming nowadays. And in DFCCIL, there is one more rail also they are using, that is called 68 kg rail. So in Indian railway track it is not there, only DFCCIL only it is there. So that is they are running one parallel track along with the railway track. So for them also our people only going there and working in the DFCCIL. So now at present you have to remember in Indian railway we have 52 kg rails, 60 kg rails and 60 kg modified rails. So now the picture what you are seeing on the PowerPoint is 52 kg rail. Sir, how do you know that it is a 52 kg rail or a 60 kg rail and a 68 kg rail? It is very simple. So one way of remembering is whenever 52 kg rail is there, so if you have a small scale and all, also you can see the top. So rail is having the minimum these parts. The top one will call it as a rail table. The top, that means 67 it is written now. So that place will call it as a rail table. So this portion will call it as a rail head. A rail head is this. This bottom portion, that means below the rail head, will call it as a rail web. The bottom is rail web. That means in between rail foot and this one will call it as a rail web. The bottom portion, it is called as rail foot. So mainly these four parts are important. That is rail table, rail head, rail web and rail foot. Okay. So the dimensions also I have given to you here. These are all in millimeters. So that means rail table width is 67 mm. For example, rail foot width is 136 mm. The height is 156 mm. It will be there. So in the center, we'll call it as at 75 point this one. So we'll call it as the neutral axis. Neutral axis, the dotted line shows the neutral axis. Why the top is given little thicker and bottom is thicker, and in the rail web area it is narrow. Okay, so that is and all separate discussion we have to make it. So now you have to understand this is called flat footed rail. This is called 52 kg flat footed rail, and these are the dimensions. Then next, one more thing. So whenever you will go to the derailment spot, you have to understand two more things. So that is the rail head area. So one is left side, another is right side. So one side where our flange, okay, is sits, that area is called as gauge face. Okay, that is called as gauge face. The other side will call it as non-gauge face. Okay, I will show you in the picture also. Say for example, you come back this picture. So this is the rail table. So where flange, here you can see wheel flange is there. So this side flange area, this is called as a gauge face of the rail. This is called non-gauge face of the rail. Just take a annotation. Are you able to see? So 1 minute, I will take the annotation also. So this is called gauge face. This is called non-gauge face. So are you getting my this annotation? That lines what I am making, is it visible? So this only I am telling you about gauge face. Gauge face is this side. Non-gauge face is this side. That means how to identify? So you have to identify based on the flange. So this is the flange. Okay. So where flange is sitting, so that is called as gauge face. Okay. So why it is called gauge face means any track measurements we will do it in a gauge face only. So this is the gauge face. This will call it as a gauge face. This is called as non-gauge face. Non-gauge face. So any doubt for anybody where is the gauge face and non-gauge face? No doubt, no? Right. So now, sir, why this gauge face is important for us is very simple, because like our wheel gauge 1600 in the case of a wagon stock and coaching stock, 1596 in the case of a loco stock will measure. Similarly, this rail gauge also they will measure. That rail gauge must be 1676. So here you can see. So here, if you are able to see, this and this, see here, this is the rail, okay, table. Similarly, this is the rail table. from the rail table, please understand what I am telling you, 13 mm below. 13 mm below, you mark it on gauge face, 1 point. And similarly here also 13 mm below, from the rail table you mark it. If you join this line, this must be equal to 1676. So 1676 means, here I will draw separately if you are not able to follow. Just see here, say from here to here, this distance we'll call it as a track gauge. This will call it as track gauge, not wheel gauge, track gauge. Track gauge, if it is 1676, it is called as correct gauge. 1676 millimeter if it is there, it is called as correct gauge. Suppose say in the derailment spot, you went there you have measured, it is 1680. So it is 4 mm slack. So you have to call it as plus 4 mm. 4 mm slack. So how 4 mm you are getting? So 1680 minus 1676. So it will be called as 4 mm slack. So slack means isse jada. That means more than 1676. Okay. 1676 say if it is more, that is called as slack. Suppose say you are measured in some derailment spot, you got it as 1672. 1672 means 4 mm tight. So that will be called as minus 4 mm. So whenever minus word is used, so that is called a tight gauge, and plus if it is used, that is called a slack. Okay. So it may be more also. Just example I am giving. It may be some 10 mm slack or 5 mm tight. Like that also it will be there. Even one of the derailment, so I have seen 40 mm slackness is there. So like that, if the more slackness is there means, so the derailment prone is very high. That means on track only, the fault is with the track. So therefore, slackness is maximum permitted is on the straight line track, straight line, it is minus 6 to plus 6. That means plus 6 means 1676 plus 6. So that is 1682 tak okay, normal. Okay. Even curved tracks and all up to 20 they are permitting. Okay. Curved track. So curved track, they will permit up to 20 mm. So this and all we'll see later. First you have to understand. So track gauge is equal to 1676. So where to be measured, that also you have to understand. So that is 13 mm below this and 13 mm below this if you join this one. So do not, some people may be having a confusion that it may be from center of this rail to center of this rail. That is not correct. Okay. So even before joining the railways, I also understood that track gauge 1676 or we used to study before preparing for the examination 1.676 meters for broad gauge. So that is also same as this only. So that is 13 mm below this, 13 mm below this. That is 1676 in millimeters, 1676 in meters, 1.676 meters. So this must be very clear for all of you, and it is to be 13 mm below. Okay, 13 mm below you have to measure. Then only it will be called as 1676 is the track gauge, correct gauge. If it is above, slack. If it is below, tight. Okay. So I hope it is clear what is the track gauge. Track gauge is clear. Okay, okay, right. So now, once gauge is clear to you, now we'll go to again to this one, rail. This is the 52 kg rail. So in this first, whenever you are going to the accident site, in that accident site area, what is the type of track they laid? That is 52 kg track or 60 kg track or 60 kg modified track. What the type of track they provided, that also you have to understand. So first, because many of the mechanical engineers do, that means many of you may be knowing, some of you may not be knowing, what is the meaning of 52 kg rail. So 52 kg rail means, say this is the rail structure. Okay, anyway picture is there. But what I wanted to tell you is, so the meaning of this 52 kg means, This is the rail cross section. If you cut a 1 meter length, if you cut a 1 meter length of a rail piece, so this length is 1 meter. Okay. So 1 meter piece length, if it is approximately 52 kg, so that rail used is 52 kg rail. Okay. So if it is approximately 60 kg, so that rails are called 60 kg rails. If it is approximately same 60 kg, in that also some profile change is there that I will explain to you. So that is also called as 60 kg modified rails. So like this 52 kg rail, actually technically speaking, it is 52 kg per meter. Okay. 52 kg per meter length. That means 1 meter length of rail piece, if you weigh if it is approximately 52 kg. So suppose if it is 51.5 you got it. So it does not mean that it is not 52 kg. 52 kg only because of the movement of so many wheels over the rail. So it is 0.5 kg, it is reduced. That is the meaning. So don't understand that sir 51.5 kg rail, that and all will not be there. So in railways, either 52 kg or 60 kg or 60 kg modified. That's all. Only 3 types of rails are available in broad gauge. I am talking. Okay. So now this 52 kg per meter rails nowadays are outdated. Why it is? Yes. Anybody wanted to ask me anything?
No, sir.
Are you following what I am telling you? Okay, right, good. So, in railways, nowadays, this 52 kg per meter rails are vanishing. Okay, why it is vanishing means, because as you know, the wagons, okay, the wagons and the locomotives and all, we are getting a new locomotives, we are getting new wagons, we are getting, and the railways motto also, it is changed because we wanted to run heavy loads on the rails. So, now, this 52 kg rail, every rail is having some capacity. Okay. So, this 52 kg also is having some capacity. Okay. This 52 kg rail capacity, it is 22.5 ton only it will take a axle load. Axle load, it will take a 22.5 ton only design. So, that means say you are moving one locomotive. Say this is the locomotive. So this locomotive means you will be having say 3 axles in the front bogie and 3 axles in the rear bogie. Okay. That means 6 axles will be there for a locomotive. Say the locomotive weight, suppose in our KJM if you see, we are having the WDG4 locomotives. So WDG4 locomotive, the total weight is new wheels and all. It is 126 ton. 126 ton. So 126 ton is carried by 126 ton is carried by 6 axles. So if you divide with 6, so you are going to get a 21 ton. That means this loco is permitted on this track. That means 52 kg rail ke upar or over that I can move because axle load is 21 ton. Suppose 21 ton, if it is more than that, say 21 ton say more, say 22 ton, 23 ton. So if you are carrying what will happen? It may break. That is, these rails may break if you are carrying more than that. For example, one more example I will tell you, say one boxen. Say boxen will be having 4 axles only. So 2 in the front, so 2 in the rear. Say the empty weight of a boxen wagon, if you see, approximately 22.5 ton to 23 ton it will come. Say this is loaded with some 70 ton or a 68 ton load. So 68 ton iron ore plus 22, so it will become as almost 90 ton. Okay, so this 90 ton is to be carried by 4 axles. So 90 divided by 4. Okay. So 90 divided by 4, so it will be 4 2 8, so 10, some 22, okay, so then 2. So almost we are reaching this tonnage. So whenever this tonnage is there, because our traffic people as well as commercial department. So instead of 68 ton, if they are loaded to some 69 ton or 2 ton extra or 3 ton extra and all, what will happen? It may cross this 22.5 ton. Then automatically there is a chance of breakage of 52 kg. So that may likely to takes place. Axle load exceeds more than 22.5 ton. That means we cannot carry more load over these 52 kg. That is why the railway board has taken a decision. So whenever we are replacing all the rails, so it has to be replaced with 60 kg only. Okay, it should not be with 52 kg. That is why manufacturing itself stopped 52 kg per meter rails. Manufacturing is stopped. The reason is because railway board wanted to have more the tonnage. Sir, why more tonnage? Because railways revenue, so that means whatever the salaries we are getting and all, so that depends upon the number of loads that is carried by our wagons. Okay, so as you are all aware, known, so our income, railways income is 60 to 70% only with freight loading, and remaining 30% we are getting from the passenger. That means if you are able to run more goods, so then railways will get a more profit. Okay, if you are running passenger trains and all, railway will not get a profit. That is why that is one issue. Then another issue is, suppose here I told you, if it is 90 ton, we are getting 22.2. Suppose if I wanted to load 100 ton, so 100 ton, if I want to on each wagon 100 divided by 4, so 25 ton will be the axle load. So if 25 ton axle load, this track is not permitted. That means this 52 kg rail track is not permitted to run 100 ton bogies or 100 ton wagons. 100 ton means, I mean to say, including the tear weight. Tear weight plus around 73 something, it will be there. So total tonnage, if it is carrying on the same one, this one will damage. That is one issue. And one more issue is our bogies also will get a hot axle. So hot axle, one of the reason is overloading by this commercial department. So these are all problems are there. Sir, if it is advantageous to carry more tonnage or not? Yes, it is advantage. Why? Because revenue for the railways, say in this wagon, for example, 68 ton, say railway is charging, say, some 50,000 rupees, for example. Example only I am giving. They will charge more also. So 50,000 rupees there. Suppose if you are carrying, say, some 75 ton, so another, say, 5,000 rupees extra on each wagon. So 5,000 rupees on extra on each wagon means, so we are running 59 wagons. So 59 into 5,000. So almost some 3 lakhs rupees extra railway will get on each rake. So that is why if more tonnage, if it is running, so railway will get more revenue on the freight. So that is why in future we wanted to run more tonnage wagons. Okay. So similarly design also will change it. That and all different. So that is why what we wanted to do is, so hereafter all 52 kg per meter rails will be changed to 60 kg per meter rails. So that is the one of the reason for a railway transforming from 52 kg per meter to 60 kg per meter. This is one advantage. The another advantage is, one more thing is, we are nowadays, we are running more traffic. Suppose now our Honorable Prime Minister Saab started introducing these Vande Bharat Express, then Rajdhani, Shatabdi, like this more trains we are running. That means, so in my childhood, only one train now, then after 1 hour or 2 hours only one more train. Nowadays it is not like that. So we are running every 5 minutes, every 10 minutes, one train. That means traffic is increased. So whenever traffic is increased, so that means fatigue loads also will generate more. So due to this traffic increase, also this 52 kg rails and all, so it will not tolerate. So why the traffic will affect, that also I will explain to you so that you can understand better. Okay, what is the traffic will affect the 52 kg rails? I hope, are you following what I am teaching to you? Okay. Good. 60 kg per meter rails only. Okay, right. So now, the reason for railway is changing to 60 kg per, this is the, here 52 kg only I have shown you. Next slide, next PowerPoint I am having a 60 kg per meter rails also, that I will discuss. The next thing is, say come back to our rail and wheel. Say here I have shown you, this is the rail, this is the wheel. Okay. Total we'll call it as a wheel set. This will call as wheel set. One wheel set. Wheel set means both the sides wheel disc will be there, in the center axle will be there. That is called as a wheel set. That terminology we use is wheel set. Wheel set means both the sides wheel disc, in the center if you are having one axle, that will call it as a wheel set. Only wheel means only one side. Okay, either left side or right side. Right. So now, always please remember, our wheel, say this is the wheel. This wheel width, if you see in the coaching stock as well as wagon stock, this we are maintaining to 127 mm. 127 mm. Okay, 127 mm we are maintaining in this wheel width. But in the locomotives, we are maintaining 132 mm. I am talking about locos. In the locomotives, we are maintaining 132 mm wheel width of the locomotives. That means wheel width of a locomotive is higher. Okay, but whereas the wheel width of the coaching stock as well as wagon stock is less. That is one thing. The next thing you have to understand is this one. Okay, this is called a flange. This is called a flange. And this is called a tread. This and all everybody knows. Okay, this is a tread. What you do not know, that also I will explain. What you know also, something I will repeat also. This is called a tread. Where tread and flange will join together, this area plays a vital role for derailment and all. So this area, we call it as a root, okay, or a root of flange. This is called as a root, okay, R-O-O-T, root, right? So now this discussion will make it a little later. You have to understand here mainly three parts. So one is called flange portion, then another is called a tread portion, another is called a root portion. I hope up to this it is clear. It's clear. Then still some more details are there on this. Oh, that also will tell you. Now this tread, okay, it will be there 1 in 20 slope it will maintain. Tread, it will not be straight. It will be 1 in 20 slope will maintain. 1 in 20 tread. Similarly, this rail table also, this is called a rail table. This rail table also 1 in 20. So here, so some people may be having a confusion. Sir, rail table, it is not 1 in 20. So we have not studied like that. Actually, this is 1 in 20 is not actually rail table. It is on the sleeper. This is called PSC sleeper. That means pre-stressed concrete sleeper. So this 1 in 20 okay, slope, they will maintain here in this portion, they will maintain 1 in 20. Okay. So that means if you see the sleeper like this will be like this. Okay. So that means here I am talking in this area where our rails are laid. So that area they will maintain 1 in 20. So over this, if you make it one horizontal line, automatically 1 in 20 only it will get. That means it is indirectly 1 in 20, directly on the sleeper. Sleeper will be 1 in 20 directly. But rail we are placing on over the sleeper. So that is why this rail also will get a 1 in 20 slope. So 1 in 20 on rail table also you will get it. Okay. 1 in 20 slope on the tread portion also it will be there. Okay. So if it is not there 1 in 20, what will happen and all that we will discuss later. Okay. 1 in 20 it will be there on the rail portion And similarly, on the tread portion also 1 in 20 slope will be there. I hope it is clear to you up to this. Okay, right. Now, one more point I wanted to tell you. Say, this wheel set, this is the wheel set, I'm talking about total wheel set. So, wheel set, it is moving over the rail table. It is moving over the rail table. Then only, if it is not moving, so we will not get any profit to the railways. So, our main aim is our wagons has to move, our coaches has to move, our locomotives has to move over the rails. So then only we will get the railway revenue. If it is a standstill condition, so then no derailment, so we will not get anything. So therefore, our wheel set has to keep on moving over the rail table. So rail table ke upar they have to move. So whenever this wheel set or wheel disc is moving on this, so you will find there will be always some gap between the flange, okay, and the gauge face of the rail table. So there will be always some gap will be there in some of the times gap will not be there. This gap, I will call it as a play. Play means the gap between this flange as well as the rail table. So are you able to see the gap, all of you? I will zoom it and show you. Yes, bolo.
Start off with failure, sir. Start off with failure. That's coming from scientist.
Okay, madam ke paas jaake. Okay, right. Are you able to see this one gap, all of you? Right. So I am talking about this only. This one. Okay. Here, the technical term I am using it is play. This is called a play. Play. Okay. So this play, it is a fixed actually. Say here we are seeing it is, for example, say right side. Right side play. The left side also will be having a play. So that means the left play plus a right play, left play plus right play. In the case of coaching or wagon stock, it is equal to 19 mm will be there. Okay. How this 19 mm came, I will explain to you. So I am repeating once again. The left side play plus right side play, this is equal to 19 mm. Okay. Sir, this 19 mm, both together it is, not one side or right side. Okay. Suppose for example, left side play is 0, the right side must be equal to 19. Suppose the left side some 2 mm if it is there, then right side play must be 17 mm. If it is 5 mm, so then this side it will be 19 minus 5, 14 mm. So that means this play will keep varying from one side to other side. That means 0, say 1, 2, 3, 4 like that, it will continue up to 19 mm. So whenever this will left side continues up to 19 mm, the right side will be touching. Okay, this will be 0. Okay, so 0 to 19 mm it will change and this will reduce. If this is increasing, this will reduce. So that means this play constantly it will be maintaining 19 mm. So what is this play, sir? How I can imagine in the case of this one? So we have one video. So that video I will play you. So that video you can understand how the play is changing. So when the play will change, whenever our wheel set it is moving over the rail table, this play will keep changing from 0 to 19 mm. Say first time, say here we will having 7 mm. The left side also, so 19 minus 7. So 19 minus 7, 12 mm will be there. So that means total play always fixed. This is fixed. 19 mm is fixed. Remember how this 19 mm is calculated is, say between the wheel gauge 1600, rail gauge 1676, your flange thickness 28.5 mm, that is new wheel. Then play is calculated, 19 mm play is calculated. Suppose say, sir, my flange thickness came to some 27 mm. So 27 means 1.5 reduced this side. So this side also 1.5. 1.5 plus 1.5, 3 mm. So 19 plus 3, 20 mm play will be there that time. And suppose gauge, slag gauge it came. Say 1676 is the correct gauge. Suppose say track is having a some 1680 if it is there. So that means 4 mm slack. This 4 also will be added here. So that means 25 mm play will be there. That means this 19 mm is calculated assuming that the wheel gauge is 1600 mm, track gauge is 1676 and wheel is new, that is 28.5 mm flange thickness. So then only you will be getting 19 mm play. So that calculation part I will show you now. So now I hope you understand what is play I am telling you, and this play why it will vary. So it may vary because of the flange thickness reduction. And suppose say instead of maintaining 1600 mm, you are maintaining say 1596 is the wheel gauge you are maintaining, 1599 if you are maintaining, for example. So 1519 means here 1 mm extra is there. That 1 mm will be added here. So this play will changes based on these parameters. That means if you are not maintaining say 1600 wheel gauge, the play will change. Suppose the track persons not maintaining 1676, they are maintaining more. So then also play will change. Then this flange thickness instead of 28.5 mm. So our JEs and SSCs who are maintaining coaching stock and all, so they are giving flange thickness up to 22 mm permitted, sir. So 22 mm permitted if you are allowing so 28.5 minus 22, so it will be 6.5. So 6.5 one side plus 6.5 13 mm that will be added. So that means these are all different parameters that will influence the play. So play will get influenced by these parameters. Once again I will repeat, that is wheel gauge it will influence, then flange thickness it will influence, then the gauge, track gauge it will influence the play. So now this 19 mm, whatever the calculation I am telling you, that is assuming that the new wheel and correctly 1600 mm, then correctly 1676, then only 19 mm play will be there. Otherwise it will be more play will be there. So the play concept, it is clear to you or not? Play concept is very, very important that everybody must understand. So how it will be getting influenced. Okay. So here, how the play is calculated, you can see here. So now this is again repeat. So this is the wheel gauge. This is 1600 in the case of coaching or wagons, 1600. And this is from here to here 1676. This one. This is 1676. This is called a gauge of a track gauge. Okay. So then this is called a flange thickness, that is 28.5 mm. This side also 28.5 mm. So if you substitute these values in this formula, are able to see all of you how the play calculation for coaches and wagons for a broad gauge? Okay, I am not talking about meter gauge and narrow gauge, you forget about it. 1676 is the track gauge minus wheel gauge, that is 1600, plus flange thickness right side, flange thickness left side, 2 flanges will be there. So 2 into 22, 28.5. So if you sum up these things and subtract 1676, you will be getting 19 mm is the play. Okay. So this play is, that is sigma left plus sigma right together. This is 19 mm. Okay. It is not left side alone. It is not the right side alone. Here I told you one more word. The actual play can be different from the standard play owing to the tolerances and other wear of the rail and wear of the our flange. So all these things also get influenced. So I hope it is clear to you. Play, what is play? Understood or not? Okay. This play is very, very important. Play is very, very important. Okay. So now I will show you one small clip, video clip, so that how the play will changes from left rail to left wheel to right wheel to left wheel, how it will changes. Just you can see that play. Then we'll come back to this further discussion.
से कोई खतरा नहीं होता है, लेकिन फिर भी अनहोनी से बचाए रखने में ये फ्लिंजेस बहुत काम आते हैं। अगर किसी मूवमेंट के दौरान व्हील्स ट्रैक से फिसलना भी चाहें तो नहीं फिसल सकते, क्योंकि यहाँ पर
are you able to see now? Once again I will play.
खतरा नहीं होता है, लेकिन फिर भी सिक्योरिटी के लिए अगर मूवमेंट तेज हो गई तो अचानक से कुछ भी हो सकता है। और
are able to see all of you this video?
अनहोनी से बचाए
see here, one side you concentrate, one side play, it is changing. Any left side or right side you see.
यहाँ पर से कोई खतरा नहीं होता है, लेकिन फिर भी सिक्योरिटी के लिए अगर मूवमेंट
वो play is keep changing.
अचानक से कुछ भी हो सकता है, और उसी अनहोनी से बचाए रखने में ये फ्लिंजेस बहुत काम आते हैं। अगर किसी मूवमेंट के दौरान व्हील्स ट्रैक से फिसलना भी चाहें तो नहीं फिसल सकते, क्योंकि यहाँ पर
clear all of you?
नहीं होता है, लेकिन
okay, so from this view that is one side, another tread contact is one side, and flange contact. That means, say for example, right side rail touching. So that implies that right side wheel disc is having 2 points of contact. So that is, one is a tread contact, another is called a flange contact. Similarly, say the wheel set, it is moving like this side. That means this side if it is touching, so this side it will be having 2 contacts, that is flange contact and a tread contact. This side only tread contact. So the meaning of flange contact, tread contact, it is clear to you?
Yes sir, clear sir.
Okay? Is clear or not?
Clear sir, okay sir.
Okay. So whenever play is 0, any one side, say for example left side is 0. What is the play of the right side? It will be 19. So right side 19, left side 0. So that implies that left side will be having 1 tread contact, 1 flange contact. This is the left side. Right side only tread contact. That means totally 3 contacts if it is touching. Suppose sir, this side is say sigma L is equal to some 6 mm. Sigma R is equal to 13 mm. That side how many contacts will be there? Only 2. Because left side also gap is there, right side also gap is there. Okay. So that side then only 1 tread contact here, 1 tread contact. Then similarly this side also tread contact. No flange contact. That means if there is a gap between left rail and right rail, similarly there is a gap between right rail and flange. So gaps are there in both the sides. Only 2 contacts will be there. That is tread contact left side, tread contact right side. Whenever one side if it is becomes 0, that time only flange contact will come into picture. So the maximum number of contacts will be either 3 or 2. Okay. Normally majority of the cases it is 2. That very few cases it will be 3. Okay. So Flange contact and thread contact clear to you or not?
Clear, sir. Noted.
Okay. 1 minute. Prabhuji. Okay. Right. Noted. Okay. If the flange is touching to rail table, okay, then in that case, one additional contact will come into picture that is called as flange contact. Okay, this once again I will explain, then we'll go ahead. Please see here. So what is this line? What I have drawn? See here. This is a wheel profile. Okay, wheel profile. If you take a point on the flange, tip of flange, if you take it, or this point if you take it, any one point, if you draw a trajectory like this, so this point it is touching here and it is giving a gap. That means in this position you have to imagine that the rail will be like this, the wheel must be like this, like this you have to imagine. That means here less amount only will be there on the rail table like this it will be there. So this is the meaning. Suppose if it is goes this side, so this side will be little far, it will go like this it will go. Suppose if it is going here, it will go like this. Okay, like this you have to imagine. So from this you have to understand that the path traversed by the wheel set over the rail table is of a sinusoidal motion, not on the straight motion. It is called a sinusoidal motion. Okay, sinusoidal motion. Okay, any point you take it on the say wheel set, any point if you take it, you will be getting a path like this. Okay, so here it is touching, here it is not touching, here left side not touching, right side it is touching. Okay, right side touching. So if left side touching, please remember right side it will not touch. Okay, if it is left side, this is left, this is right. Right side touching, left side will not touch. Any one side it will touch. Both the sides it is not touch unless there is a very high irregularity. Then only it will touch. Otherwise it will not. Okay. So that means this is the normal movement of our wheel set over the rail table. Rail table ke upar. So this is the way. This sinusoidal movement. So due to this sinusoidal movement, I told you, whenever this side touching, you will be getting 3 points of contact. Whenever this side touching, this side only another point of contact extra it will be there. That is totally 3. Whenever touching 3. Okay. So that is thread contact, flange contact. Similarly here also only thread contact in this area. So these 3 contacts, it will go on, keep on moving like this, either this way or reverse. Anyway, it will keep on moving. That is thread contact 2 times, normal. So in the case of touching time, 3 contacts, that is 2 plus 1. 2 plus 1. 1 flange contact, that will be there. So, sir, what is the effect of this flange contact? What is the effect of this flange contact? So, this effect of flange contact only may likely to climb over the rail table. So, if this flange contact, if it is having any problem in this, then it may likely to climb over the rail table. That is also known as flange climbing over the or mounting over this one. Okay, that will leads to derailments and all. That means derailment condition will come into picture whenever 3 contacts are there. That is 2 thread contacts and 1 flange contact. Whenever 2 contacts are there, that is only 2 thread contacts. That implies that left side also gap is there, right side also gap is there. If there is no gap, that implies there is one more additional contact is there. That is called 1 flange contact. So that is why here you have to understand very neatly about what are the forces that are causing whenever additional flange contact is there, what will happen to the rail and wheel. That only designed by one famous railway engineer. His name is called Nodal. Okay, Nodal studied about whenever one flange contact and two red contacts are there, what is its effect on the rail wheel forces. He designed one theory that is called as Nodal's formula. After this, the other scientists also, engineers also came up. So this is the Nodal is the first person. Okay, he seen what the influence of this flange contact. Here also you can see whenever this is hitting the rail table due to the flange contact, one additional force is falling here. Okay, that force we'll call it as a flange force. Okay, this flange force is nothing but horizontal force that in which it will hit the rail table from left to right. So then after hitting here some amount of time, that few seconds, it will not hit both the rails. Here again it is hitting. Then after that it is here hitting. That means this flange force is not a continuous force. It is an instantaneous force. This flange force will act on the right rail one side, on left rail one side, again right rail, again left rail. Like that it will keep on applying the flange force. What is the flange force? It is the force in which it will hits the rail table, some particular force. That force is called as a flange force. So what is a flange force? It is clear to you or not? What is a flange force? And why it is not a continuous force also? It is clear?
During point of contact, it will apply the force.
Yes. Whenever there is a one additional flange contact, that is whenever one side say the play is 0, so that time only it will hit. Okay. So similarly, after a little movement, it will hit left side, then right side, then left side, then right side. It will keep on moving like this. Suppose that time, if the track is weak, while hitting it, so that time what will happen? It will move this side. That means the gap between the, that means 1676 mm gap will increases. That means once again come back to the picture. Okay, so here our civil engineering friends, so they have fixed one pandroll clip here, one more pandroll clip here. So this pandroll clip, if it is not there, what will happen? Because this is the flange. So this flange, I told you, whenever it will hit like this, so this rail also will move. Okay, so the rail will give earlier it was 1676. Since this is moved, say this is missed. Say this pandroll clip is, imagine that it is missed continuously. Here it also missed, left side, second also missed, third also missed. So all these places it is missed. Then what will happen? Because of our flange force, it will increase us to 1677, 1678, because like that it will keep on, because this is only one wheel set. Say in the case of a locomotive 6 wheel sets, in the case of wagon 4 wheel sets, in the case of a coaching stock again 4. So like that total coaches, 22 coaches, say for example one locomotive. So one locomotive 6 wheel sets plus 22 into 4, 88. So totally, so 88 plus 6, say 94 wheel sets will keep on hitting like this. Then automatically this will work. That is why, so there is always the permanent way persons, they will maintain one trackman. This trackman duty is whenever there is a slack of this one or missing of this pandroll clips, his duty is to insert and bring back to the normalcy. That means the flange force you are applying and it is going back and it is damaging. Again, tomorrow, the next day, the trackman will make it ready and bring back to 1676 by inserting this pandroll clip. Clear to you? Okay. What are the influence of the flange force it will create over the track? It is clear? Clear or not?
Yes, sir. Clear, sir.
Suppose this is a normal phenomena. This flange force hitting this flange force is a normal phenomena. Whenever train is moving over the rail table, it will keep on hitting. Okay, it does not mean that it is hitting here and the same place it will hit like that. It is not there. That also depends upon the different diameters and all. Suppose a locomotive, it is having a highest dia, say 1092 mm. For example, in the case of a coaching, 915 mm. In the case of a wagon, 1000 mm, the new dia. So like that, based on the dia and all, the places may change, but hitting is compulsory. Okay, hitting is compulsory. Okay, flange force is a common phenomenon. So for that only they have to tolerate. The track has to tolerate. It will not move this 1676 badne nahi dena. So which is not maintaining. So not increasing this one, this fan roll clip. If the fan roll clips are strong, so even though our wheel set it is hitting with the flange force, it will not go out. It's clear?
Clear, sir.
So that is why the track man is very, very, very important. Every day he will go over some 5 kilometers or 10 kilometers. So then whatever the flange forces that are occurred and what are the damages that is happened to the fan roll clip, then liners and all, he will replace and he will keep on moving. So he is the safety person. Okay, like our C&W person who is checking the wheel set and all. Similarly, this person also very, very, very safety person. He has to keep on maintaining all fan roll clips are intact, inside, outside and all. He has to do. That is why this fan roll clip missing items also we have to measure. Okay, at the time of derailment. At the derailment, if it is missed, you have to see. Missed means that particular area, you have to understand that gauge may likely to increase. Okay, but practically what is happening in so whenever we are going to the derailment spot, by the time the engineering persons will fit all the these fan roll clips. That and all a different story. Okay, what they are doing and all. So remember the influence of the this one is because of this one, it is not tolerating. It is moving out. Flange force, any doubt for anybody?
No doubt, sir. Clear, sir.
Flange force.
No doubt, sir.
Is the flange force is a continuous force or intermittent force?
It's an instantaneous force, sir.
Yes, exactly. It is an instantaneous force. It is not a continuous force. Right. Now, in addition to that, one more force is also there. So that is called vertical force. Okay, see this diagram. Are able to see this picture, all of you? Are able to see all of you this picture?
Yes, sir.
Right. Now, this is the rail table. This is our wheel profile. This is the left side. Okay. Similarly, you can draw reverse. It means you will get a right side. Okay. So this is our flange here. This is the wheel profile. So about this force I explained. Okay. About this force, how it will come, I explained to you. And point of contacts also I explained. Now you have to understand this. What is this vertical force? What is this vertical force? So how it will come? So this vertical force already I explained a little, but you have to understand once again. Say this is the locomotive. This locomotive weight, say for example, WDG4, 126 ton. ಸ್ವಲ್ಪ ಟೈಮ್ ಬಿಟ್ಟು ಬನ್ನಿ. 2 o'clock ಬನ್ನಿ, ಊಟ ಆದ್ಮೇಲೆ. So WDG4, 126 ton. Suppose say if you see now in KJM shed, we are maintaining even electrical locos also. We are maintaining a WAP 7 locomotives. We are also maintaining WAG 9 locomotives. The WAG 9 locomotive, the weight of this one is 132 ton. The weight of WAG9 locomotive, I'll repeat once again. The weight of WAG9 locomotive, it is of 6,200 horsepower, 132 ton. Suppose 132 ton if you replace here, 132 ton if you replace, divided by 6 axles, same 6 axles here also. So 6 2s are 12, so again 12, so it is 22 ton. That means on each wheel set, say this is the, imagine this is the wheel set. Here it is falling 22 ton. So 22 ton, actually it will not act here, it will act here, okay? But anyway, the total load I am telling 22 ton axle load. Okay, this 22 ton on each wheel disc if you see 11 ton. That means here it will be 11 ton it will act. That means on this 11 ton, on this 11 ton it will act. So that load is a continuous load. This 11 ton load of my WAG9 locomotive, it is a continuous force. So this is called a vertical force. The vertical force comes from its own weight. Okay. If wagon is loaded, so then also the load will come. Okay. Wagon is empty, some 22.5 divided by that 4. Okay. That will come. So that means this 11 ton, it is nothing but vertical force. Vertical force comes from the own weight of that particular either loco or a wagon or a coach or whatever this one is there, divided by number of axles, divided by 2 on each wheel it will come. So that force is called as a vertical force. So vertical force will be continuous. It is a continuous force. But lateral flange force is instantaneous force. So these two are important forces. Vertical force comes from own weight. Lateral flange force will come from sinusoidal movement. Okay? Is clear to you? Vertical force कहाँ से आया? Lateral flange force कहाँ से आया?
Yes, sir. Clear, sir.
It's clear?
Clear, sir. Got it, sir.
Right. So now, whenever any wheel or a wheel set it is moving, okay, either locomotive or a coach or a wagon if it is moving, always two forces will come into picture. One is called vertical force, another is called lateral flange force. So this is the instantaneous force, but this is the continuous force. Okay. So because of this vertical force and lateral flange force, one instant if you take it, okay, where the flange is touching the rail if you take it, additional forces, because as you said, so some Newton's third law, what it says, suppose somebody applied on one, say, if you are applying some F force, then as per the Newton's third law, there is every equal and opposite reaction also will be applied by the other force. So other forces, this is called a normal reaction force. This force is reaction force, normal reaction force R. Okay. So because this is a metal and this is also a metal, so therefore one more friction force is there, that is called as a frictional force. This is F is a frictional force, R is a normal reaction force, and Y is the lateral flange force, Q is the vertical forces. So I hope it is clear to you what is R, what is F, what is Y, what is Q.
Yes, sir. Understood, sir.
Direct forces are these two only, Q and Y. These two are indirect forces. That is a normal reaction force and frictional force. Okay. So what is this beta also I will explain now. What is this beta I will explain. Say, so normally, say this is the wheel profile. On this wheel profile, if you draw one line like this with reference to the vertical, come in please. This angle is called beta. Beta for, yes?
So one set of locomotives.
came from?
Sir, publishing, sir. Kal aaya. Name AC compressor.
What do you want actually?
One set walls compressor.
So this angle equal to beta. This beta for wagons, okay, coaches and all, they will maintain roughly around 70 degrees. 70 degrees they will maintain. For loco and all, we are maintaining 68 degrees. So whenever this angle becomes 90 degree, this angle, whenever this wheel set is moving over the rail table, this 68 degrees will become 69, 70, 71, 72. It will keep on increase. So then finally it will reach a stage. So that is called like this. That is also called as sharp flange. So this angle between these as sharp flange. Okay. So that is why for locos and all 68 degrees we are starting. For coaching wheels and wagon wheels and all we are starting at 70 degrees. Okay. This angle is very, very important for us. Okay. If it is becomes 90 degrees means it is called as sharp flange. Sharp flange means the beta when it is becomes 90 degrees, that is called as sharp flange. Okay. So the beta value understood all of you?
Yes, sir. Understood, sir. Sir,
Right.
short flange or less to trade, sir?
Sharp flange. Sharp flange means that means 90 degrees. I'll repeat like this. Like this. Then other also will come. Okay. Here I am talking about beta purpose. The other parameters also less root radius. Also those things also will come into picture. Here I am talking about beta. Okay. When beta will become 90 degrees, it will causes first sharp flange. If sharp flange is there, then what will happen? This flange thickness will become very less. So whenever points and crossings, when it is moving a locomotive, say this is the points and crossing. Okay. So it is moving. So then what will happen? Here one tongue rail, one stock rail will be there. So here it may likely to enter and it may leads to derailment. That is why sharp flange is not allowed. Sharp flange means the flange thickness is very, very less and also it will become like this. Okay, in this case, say earlier it was like this. Earlier it was like this. It will become thickness is lesser and lesser. Then it will here also sharp it will come. So that will leads to the derailments in the case of points and crossings. Right. Now we'll come back to our discussion once again. Are you able to see the picture, all of you?
Yes, sir. Visible, sir.
Okay, right. Now, here the vertical force I told you, kahan se aaya. Then lateral flange force also I told you. Then R is the normal reaction and F is the frictional force. So now, as per the engineering system, so you can resolve the components. Say this is the R is there like this. So this R is the inclined force. It is acting at a say beta angle. So any one inclined force I can resolve into one horizontal force and one vertical force. Suppose say if it is beta, this is R, this will be automatically, this will be opposite, na? So R sin beta, this will be R cos beta. Similarly, F also we can resolve into F sin beta, F cos beta. So why we have to do is, we have to apply the formula called sigma V is equal to 0 and sigma H is equal to 0. That means sum of the forces that are acting from left to right must be equal to right to left. Similarly, vertical forces that are acting from top to bottom and bottom to top must be balanced. Then there will be no derailment at all. Okay. If it is not balanced, then additional force is causing. Okay. Say for example, lateral flange force, it is dominating the vertical force. Then it leads to derailment. Okay. So for that reason, we have to apply sigma B equal to 0, sigma H is equal to 0, sigma M is equal to 0. These are called equilibrium laws. So our engineers might have studied so in our engineering mechanics subject or strength of material subject. So that if you apply, so then you will be landing in this picture. Okay, like this. So here definitions, Q is the wheel load bar vertical force, Y is the lateral flange force, normal reaction, frictional force, F is equal to mu into normal reaction, mu is the coefficient of friction. So like this, if you see, then if you resolve all of them, so lateral flange force, Y is equal to R sin beta minus F cos beta, vertical force Q is equal to R cos beta plus F sin beta, then Y upon Q, if you take it, you will get like this. Then divided both the sides by cos beta, both numerator and denominator. So then you will be getting one formula, okay, in terms of tan beta. Then finally, you will be getting one expression. This expression is called a derailment. Okay, coefficient expression, also known as Nodal's coefficient expression. So this is a final expression. Okay, so that is Y by Q. What is Y? Y is nothing but lateral flange force. Okay, this is by the vertical force. Okay, if you see this ratio of lateral flange force upon Q, if it is this is equal to this. If you take tan beta value, say for 68 degrees for locomotive and 70 degrees for this, and mu is equal to 0.25 and all, if you substitute, so then if you simplify, the value you will arrive to Y by Q is 1.4. Okay, like this. If it is less than 1.54, then it is the safe for the no derailment. If it is more than 1.4 and all, it may likely be okay. Say for example 2. What does it mean? Y is equal to 2 times vertical force. So that implies that lateral flange force is dominating the the vertical force. So that is why in the case of our empty wagons, okay, these and all will cause more derailment, means because in that case the derailments are high because of the empty wagon. So lateral flange force will dominate on the vertical force. So it will leads to derailment. It should be maintained less than 1.4. It is safe for the derailment. If it is more, it may the proneness of the derailment will increases. So this formula is developed by one famous engineer called Nodal in the year 1908. After that, so many other modifications also came into picture. Okay, so this is announced by this. This is also called as Y by Q. This how to remember is where the lateral flange force is dominating the vertical force. For example, recently a year back or 1.5 years back, one derailment is happened in South Central Railway near Maulali area. So there the supervisor committee decided that say there is a wagon derailment is there. For example, say this is the wagon. Okay. So in this wagon, what happened? Say this is the wagon top side. This is the wagon. So here the contractors loaded more here, contractors loaded less. Suppose say in the case of this one, they will load with the help of JCBs and all. So JCB may not go this side. Okay, it will go this side. So he will load here, keep, then each side it will go less. Okay, so then contractor, what he is supposed to do? He has to level it to this one. Suppose because no staff or no labor and all, so that wagon is moved like this. What will happen? One side more load, one side less load. So that leads to what will happen? The lateral flange force will be more on this. Lateral flange force is here less. Then it leads to derailment one side. Okay. So therefore, this type of cases leads to the Y will be more than the Q. Then automatically it will move up. This will be down like this. Okay. So this type of derailments also likely to happen. So here you don't try to substitute these values. Here only this formula will give us what are the situations Y is dominating than the vertical force. That only you have to theoretically you have to understand. But whereas nobody trying to do what the value of beta, what the value of mu and all, it is not this one. So only Y when it is influencing more than the vertical force, that we have to study. Okay, so the Nodal formula is also having some limitations and all. So when it is valid, okay, when it is not valid and all. So Nodal's formula is true when angle of attack is large. Angle of attack, I will explain once again. Already I explained. Okay, that is what is that angle of attack? I will explain to you. But word I have not used. Say this is the one rail, this is the another rail, left rail, right rail. Okay, please understand carefully. Here I told you, whenever there is a flange is touching the rail head this side, I told you one additional force will come, FC, point of contact, flange contact. Normally tread contact will be there. So that flange contact and tread contact, say this is the rail. So tread contact will be in the center. Flange contact will be one corner. Okay. So these two join if you together and make an angle with the vertical. This angle is called angle of contact. Angle of contact means it is the line of tread contact and flange contact. If you join together, it will give you some inclination. That inclination angle with reference to the vertical, that is called angle of contact. So based on the angle of contact also, this force of lateral flange force will get influenced. Y value will influence based on the angle of attack. Then larger lateral force area. I told you one of the example is one side wagon is loaded more, one side wagon is not loaded more. So in that case, the lateral force will be large on the loaded side. Where the load is not there, that side it will automatically get lifted up. Reduced vertical load on the wheels. That means reduced vertical load on the wheel means empty wagon. So empty wagons are more prone for the derailment. Track with a significant vertical irregularity. So track with a significant vertical irregularity means for seeing the track, it will be like this only. But actually, if a load comes on this, say wheel is moving on this, then what will happen means the track may go like this. That means it will sink like this, then go up, again sink like this. That means wherever sleepers are there, say this is the sleeper here. This is the sleeper here. So wherever sleepers are there it will not sink normally unless there is a ballast deficiency is there. There also it will sink. If there is no ballast deficiency, it will not sink here. Normally, between the two, like this concave shape it will come. Like this it will come. Okay. So those areas, what will happen? Degree of irregularity, vertical irregularity may come. So those areas it may leads to derailment. Then high degree of a track twist. What is the track twist and all? So in this one I will explain about what is the track twist and all. So these are the important reasons you can apply the Nodal's formula is applicable. Other than this, the other cases and all normally you will not apply this Nodal's formula. So this is about what is the Nodal's formula, why is important, what is its role and all you can see. So in this picture also you can understand better way. See here. Are you able to see all of you this picture?
Yes, sir. Visible, sir.
Okay, right. If you see the first picture concentrate all of you. Here Q, vertical load it is there. One TC means tread contact. Tread contact is there. And there is a gap between, or there is a play between the rail head and flange. There is a gap. So therefore, there is no, the Y force means that is lateral flange force is not there in the first picture. Come back to the second picture. This vertical load always will be there. Now, flange contact also came into existence. That means it indirectly, there is a contact between the flange as well as rail table. That is flange contact. Additionally, it is there. Whenever flange contact is there, obviously your lateral flange force also will influence. So now, for the second picture, if you see, both vertical load as well as horizontal load, both are acting. For second picture, both are acting. First picture, only vertical load is acting. Now, if this lateral flange force is dominating than the Q say upar, chale ja raha, then what will happen? It will tries to lift the wheel disc like this. Then there is a gap between the wheel tread area as well as rail table. There is a gap. Then Y is increased. Y is increased in this case. Increased more and more. Then it will lift like this. Then if you see here, the flange contact and tread contact point is same. So that is wheel is climbed over this. That is also called as point of mount. Point of mount is happened. So then over the rail table, okay, this is the rail table, okay, it will move like this. Say this is the, okay, three-dimensional view. Say this is the point of mount, okay. So then it will travel over the rail table. Then here it will drop, okay. So here it is dropping. So here once again, first picture, only vertical force is there. There is no Y. Second picture, there is a flange contact is there. Red contact is there. And Y is also lateral flange force also, okay, came. That lateral flange force normally when Q is more than the Y, no derailment. When Y is more than the Q, so then what will happen? It will leads to lifting of your wheel set. So once lifted, then both will be equal. Then there is a point of mount on the rail table. Then that point of mount on the rail table, okay, will keep on moving like this. Then finally it will leads to point of drop. So here point of mount, POM. Then last picture, it will show you point of drop. So point of mount and point of drop are very, very, very important in the case of any derailment. So whenever the mechanical supervisor or mechanical officer goes to the accident spot, you have to identify where is exactly point of mount, where is exactly point of drop. These two try to identify. If you are not able to identify at least one, so whatever it is identified, so first that only you stick on first, okay? That will act as our reference one. From there only the distances, the track parameter, track distance, how much distance, the readings to be taken and all will be influences this one. Because if any track irregularity is there, so from that particular area only, for example, say you are going from, say, one location to some Gutti to Guntakal you are going. Somewhere your purse is lost. So you cannot, check all the places where your purse is gone and all. So you may likely to where you, when you have opened your purse, where you have spent the money. So that particular area only you have to look, there is a chance of dropping your money and all. Similarly here also, whenever there is a, say, derailment, you have to look the track irregularities at point of mount or point of drop. Any one is taken as reference. Normally point of mount is very, very, very important. If this is not there only, then we have to rely on a point of drop. If you are not able to establish this, then only you have to rely on point of drop. If you are, say, both are known to us, point of mount also known to us, point of drop also known to us, then which is to be taken reference? Point of mount is to be taken as a reference, not a point of drop. If both are known to you. If point of mount is known to you, point of drop is not known, no problem. Point of mount is exactly the reference for you. So from that only say, this is the point of mount, POM point, POM. So from there, okay, ahead 45 meters and the rear, okay, 300 meters readings are very, very important. So for that only, this point of mount is a plays a vital role. Okay. So what is a point of mount means? So just climbed over the rail table, that is called as a point of mount. Sir, how to identify is very simple. See, I will draw the 3D diagram. Say this is the.
Hello, sir.
Yes.
Sir.
Tell me.
Sir, I am Dhananjay, sir, SSC Gutti, sir.
Tell me now.
Sir, ఇది పాయింట్ ఆఫ్ మౌంట్ గురించి CNW కి ఇంజనీరింగ్ కి ఎక్కువ సార్లు డిస్కషన్ వస్తుంది సార్.
వస్తుంటుంది
యాక్సెప్ట్ చేయండి సార్ పాయింట్ ఆఫ్ మౌంట్.
అది పాయింట్ ఆఫ్ మౌంట్ మీరు చెప్పించాలి అక్కడ. అంటే సే ఫర్ ఎగ్జాంపుల్ సే ఈ డయాగ్రామ్ చూడండి ఒకసారి, మనకి ఎలా తెలుస్తుంది సార్ అంటారు మీరు. సే ఫర్ ఎగ్జాంపుల్ ఈ డయాగ్రామ్ చూడండి మీరు. దిస్ ఇస్ ద రైల్. ఓకే, సో రైల్ లో మన యొక్క ఫ్లాంజ్ కాంటాక్ట్ సే ఇక్కడ వచ్చింది ఒక చోట, సపోజ్ ఇక్కడ వచ్చింది ఒక చోట, ఇక్కడ వచ్చింది ఒక చోట. సో నార్మల్ గా దీనిపైన క్లైమ్ చేయకపోతే ఇది కంటిన్యూస్ గా పోతూ ఉంటుంది. హిట్ అవుతుంది, వదులుతుంది, హిట్ అవుతుంది, వదులుతుంది. కానీ ఎక్కడైతే డీలైన్మెంట్ కావడానికి ఛాన్స్ ఉందో అక్కడ ఏమవుతుందంటే మనకి గీసినట్టుగా ఎవరో ఒక మెటల్ తో గీసినట్టుగా ఇట్లా వస్తుంది. ఇలా వచ్చి ఇక్కడ మైండ్ అయ్యి దీని మీద ట్రావెల్ అయ్యి ఎలా పోతుంది.
సార్
ఓకే, సో ఈ మార్క్ చూపెట్టండి వాళ్ళకి. ఈ మార్క్ చూపెడితే వాళ్ళు ఒప్పుకోవాల్సిందే.
వాళ్ళు యాక్సెప్ట్ చేయరు సార్ అది.
అరే యాక్సెప్ట్ చేపించాలబ్బా మీరు, మీరు యాక్సెప్ట్ చేపించాలి మీరు ఆ మార్కింగ్ ని. ఆ మార్కింగ్ చూపెట్టండి క్లియర్ గా వాళ్ళకి. సార్ ఇక్కడ నుంచి మొదలు పెట్టింది సార్ మా ఫ్లాంజ్ రబ్ అవటం మీ రైల్ సైడ్ మీద. సో ఇక్కడ రబ్ చేసుకుంటూ వెళ్ళి ఇట్లా వెళ్ళి ఇక్కడ క్లైంబ్ అయింది, ఇక్కడ కావాలంటే మార్క్ ఉంది అని చెప్పి దీనికి క్లియర్ గా వీడియో తీయండి మీరు.
సార్
ఓకే, వీడియో తీసి ఇప్పుడు ఒక మెటల్ మీద ఇంకో మెటల్ తో గీస్తే ఎట్లా ఉంటుందో అలా వస్తుంది మీకు.
సార్
ఓకే,
ఫస్ట్ లొకేషన్ కు ఇంజనీరింగ్ వాళ్ళు ముందు రీచ్ అవుతారు సార్. దాన్ని ఎలా
అది ప్రాక్టికల్ గా జరిగేటువంటి నాకు తెలుసు, వాళ్ళు అవన్నీ రబ్ చేసేస్తారు. కానీ మన వాళ్ళు కూడా ముందెళ్ళాలి, ముందెళ్ళి చేయాలి ఆ పని. ఓకేనా, లేకపోతే నేను ఏడిఎంఈగా ఉన్నప్పుడును ఎస్ఎస్సిగా ఉన్నప్పుడు ఏం చేసేదంటే మా లోకో పైలట్స్ ఫోన్ చేసి అక్కడ వీడియో తీయమని చెప్పేది. ఆ వీడియో తీసి ఎక్కడైతే ఇది ఉందో అది మీరు ముందేనే వీడియో తీసి పెట్టండి. ప్లస్ అట్ ద సేమ్ టైం ఎక్కడైతే నార్మల్ గా మీకు ఐడియా ఉందో అక్కడ ఎవరిని రాకుండా చూడండి అని చెప్పేది నేను ఫోన్ చేసి. అర్థమైందా? సో ఆ వీడియో మనకి హెల్ప్ అవుద్ది అనమాట. ప్లస్ ఎవరెవరు వస్తున్నారో ఏమిటి అనేది కూడా కొంచెం అబ్జర్వ్ పెట్టండి అని చెప్పి నేను లోకో పైలట్ కి తర్వాత గాడ్ కి చెప్పేది. ఏడిఎంఈ ఉన్నప్పుడు వాళ్ళకి ఫోన్లు చేసేసి మీరు వీడియో తీసి పెట్టండి, మీరు అక్కడ ఎవరిని అలౌ చేయొద్దు మేము వచ్చిందాకా అని చెప్పి ఫోన్ చేసి చెప్పేది. ఓకే, అలాంటి ట్రిక్స్ ప్లే చేసుకోండి. లేకపోతే లక్కీగా మన స్టాఫ్ అక్కడ ఎవరన్నా అక్కడ అప్ అండ్ డౌన్ చేస్తా ఉంటారు, ఎవరైనా ఉంటారు వాళ్ళని ముందే పంపించడం, అలాంటి ట్రిక్స్ అప్లై చేయాలి. ఓకే, ఇది ఉంది కదా ఓకే, ఈ గ్రేజింగ్ మార్క్ అంటారు దీన్ని. దిస్ ఈస్ కాల్డ్ ఎ గ్రేజింగ్ మార్క్. ఈ గ్రేజింగ్ మార్క్ ని చూసుకోవాలి మీరు. ఓకే, గ్రేజింగ్ మార్క్ ఎక్కడ ఫామ్ అవుతుంది? గేజ్ ఫేస్ ఆఫ్ ది రైల్ టేబుల్. ఓకే, రైల్ యొక్క సైడ్ ఉంది కదా, రైల్ సైడ్ మీద పడుతుంది. ఇది పడుతుంది ఇక్కడ, ఇది పడి దీని మీద మూవ్ అయ్యి పడుతుంది. సో కొంతమందికి డౌట్ వస్తుంది, సార్ రెండు మూడు వీళ్ళు ఉన్నాయి సార్ అంటారు. సే ఫర్ ఎగ్జాంపుల్ ఇక్కడ ఇంకోటి ఉందనుకోండి, లేకపోతే ఇక్కడ ఇంకోటి ఉందనుకోండి. ఏదైతే ఇప్పుడు సపోజ్ డైరెక్షన్ ఆఫ్ ట్రావెల్ ఇక్కడ ఉన్నప్పుడు ఫస్ట్ ది ఇంపార్టెంట్. ఇట్లా మల్టిపుల్ ఉంటే ఓకే, ఫస్ట్ ది ఇంపార్టెంట్, నాట్ సెకండ్ థర్డ్ అవసరం లేదు, ఫస్ట్ దే ఇంపార్టెంట్. దిస్ విల్ బి టేకెన్ యాజ్ రిఫరెన్స్. ఓకే
సార్.
సో ఇప్పుడు ఒక 5 minutes గ్యాప్ ఇస్తారు. అయితే డీరైల్మెంట్ కి వెళ్తారో వాళ్ళకి నాడల్ ఫార్ములా నా నాలెడ్జ్ ప్రకారం అందరికి తెలిసి ఉండాలి. ఈ నాలెడ్జ్ ఉండాలా అవసరం లేదా?
ఉండాలి సార్.
సో ఈ నాడల్స్ ఫార్ములా లేకుండా ఫర్దర్ స్టడీ చేస్తే వాటి యొక్క ఇన్ఫ్లుయెన్సెస్ మీకు తెలియదు. అంటే వై ప్యాండ్రోల్ కి ఎందుకు పెడుతున్నారు వాళ్ళు, ఓకే, అవన్నీ తెలియదు అనమాట మీకు. ఓకే, సో దట్ ఈస్ వై నేను డీరైల్మెంట్ క్లాసెస్ చెప్పేటప్పుడు ఫస్ట్ ఇది చెప్పి తర్వాత మిగతా చెప్తాను.
సార్ ట్రాక్ ఇన్సైడ్ గ్రీజింగ్ ఏమైనా చేస్తుంటారు సార్?
చెప్పండి.
గ్రీజింగ్ ఆఫ్ ట్రాక్
అది తర్వాత డిస్కస్ చేద్దాం. ఓకేనా?
ఓకే సార్, రైట్.
ఇది అర్థమైంది కదా ఎంత మటుకి?
సార్ గాట్ ఇట్ సార్, అండర్స్టూడ్ సార్.
ఓకే. సో మీకు ఫిజికల్ గా చెప్తే ఇంకా బాగా చెప్పగలను. ఓకే, ఇప్పుడు కూడా ఓకే, పర్వాలేదు, చాలా మంది ఇంటరాక్ట్ అవుతున్నారు. వెరీ నైస్ సార్. ఇప్పుడు నా ఛాంబర్ లో వాచ్ ప్రకారంగా 12:25 అవుతుంది. సో దిస్ ఈస్ ద బిగ్గెస్ట్ టాపిక్. ఓకే, ఇట్ ఈస్ నాట్ ఈజీ టు అండర్స్టాండ్ విత్ ఇన్ 1 hour or half an hour and all, because so many things nowadays, new developments. Okay, last 20 years back, whatever it is there. So now what is going on in the track, both are entirely different tracks. So similarly, you can imagine like this. Earlier we were using in mechanical department ICF coaches. Nowadays what happened? LHB coaches came into picture. Similarly, on the track also, I told you one clue. So we were using a 52 kg. Nowadays we are already transforming to 60 kg. So similarly, track wise lengths also, so many changes came. That means development came not only in mechanical department. So it came in the same development also came up in the track geometry also, track parameters also. So track cases also a lot of developments are coming up. Okay, still it will going to come. Okay, so that is why the reasons what we are searching earlier 20 years back, one SSE is looking for slag gauge may be there, that may be the problem for this derailment and all. So now those slag gauges and all nowadays it is not coming up because they have changed it to PCS. That means the PSC sleepers they are using. So the gauge widening and all that and all, it is an unusual thing that will not happen also. Okay, so now you have to look for the new reasons for derailments, new problems for the track maintenance. That way you have to think of, not the old pattern. So old SSEs, so they may be thinking, sir, this may be the reason, this may be the reason and all. That is why, so what I am telling for the present generation SSEs and the JEs and whoever the officers are there, so you have to study about the track perfectly. Then only you will be getting a good knowledge on the track. Okay, so this whatever the presentation I am making, it's very 5 to 10% of the track. So much of another much knowledge is there to understand about the track. Okay, so it is not easy to digest the entire track geometry in 1 hour or half an hour and all. Okay, so keeping that, so what are the important areas? Okay, from this discussion you can understand. So what are the areas you should know more? Those things also you can understand. Right. Now the topic is track observations and joint readings. This also I cannot complete fully, but I will try to complete as quick as possible some of the important things. So when you go to the accident site, so our supervisors, mechanical supervisors will go. Then other supervisors like say track supervisors, that is SSC permanent way or JE permanent way will come. So then the neutral persons like TI, traffic inspectors will come. And sometimes S&T staff, S&T JE, SSCs also will come. Even other persons also will come into the accident site. So here what are the things I have shown you 3 points. These are the duties of the mechanical supervisors. So other supervisors duties I have not shown here. If you want, you can refer the accident manual. In the accident manual, it is clearly written what are the roles of the mechanical supervisor, what is the role of a traffic inspector, what is the role of a loco inspector, like that clearly written separately. That and all I am not covering here. Here I am covering only mechanical supervisor's duty. That is mainly SSC CNW duties and all only I am covering. See here 3 points. One is whenever mechanical supervisor is going along with the ART team and all, he has to do 3 things. Re-railing and restoration of derailed vehicles. Whatever the vehicles are derailed, so he has to concentrate on restoration with the help of your ART or a crane, whatever that is there. That is one thing. The second is, if passenger train is involved in the accident, passenger train is involved in the accident and some people are injured or died, so you have to risk them. That is also second duty. So for this, you can give one SSC JE, and for this also 1 or 2 SSC JEs you can give. Then the important one for accident investigation is second point. That means this point is very, very important. So now we are discussing only on this point. Okay. First point, how to do the re-railing and restoration and how to do risking of the injured passengers. You have to visit. So IRIDM. So in IRIDM, they will teach you, okay, how to re-rail and all those, what are the tools and all, they will explain to you. Okay. So now I am not covering first point and third point. I am covering only this second point. First, you have to understand joint readings means what? Who are all the persons involving in the joint readings? Already I told you. Once again, I will repeat. Joint reading means the committee of supervisors. Okay. So that is the CNW supervisor, loco inspector, track supervisor, that is SSC bar JE permanent way. then the traffic inspector or nominated as station master or whoever is there. Sometimes in points and crossings, if it is there, so you have to involve SSC SNT or JE SNT. Suppose the loading and either problems are there, SSC commercial, sorry, not SSC, so they will be there, commercial inspectors and all will be there, okay, those will be called, then SSC TRD, if overhead rails and all damaged, so you can call overhead TRD, JE or SSC also. So these are called committee of supervisors. So remember, this is the mandatory, that means it's a compulsory. That means whenever accident is there, so you have to get it nominated at least these persons. Okay, CNW, loco, track, these three are common always. Then sometimes it will traffic also common. SNT sometimes it will come, commercial sometimes it will come, TRD sometimes it will come, not always. Okay, this point you have to. So now, after collecting this data, that is joint readings or track readings or wagon readings or coach readings, loco readings and all, to whom it is to be submitted. So first, this has to be signed by, okay, all these persons who are all there on the spot, and is to be submitted to, after signatures, it is to be submitted to one inquiry committee. You have to submit. So inquiry committee, you can submit these things, and if any taken videos, any photos, also to be submitted to inquiry committee. Okay, so all these will be taken by the inquiry committee. Who will nominate the inquiry committee? Inquiry committee will be normally nominated by DRM of that particular, okay, division. So that particular division DRM will be there. So if it is big, okay, the accident and all, so then normally GM will nominate this one, that is based on the gravity of the accident. If small accident and all, okay, sometimes DRM may say hush up the derailment. Then also DRM is having a power. Okay, suppose DRM is went on leave, then ADRM will come into picture. These and all normal things. Okay, suppose for example in our shed, Sreenivas is not there, then I will be nominated for all these things. Similarly for any this one also same way, joint readings and all, inquiry and all will be decided by DRM of the particular division. Then speedometer chart of the locomotive involved. Then SNT, if it is there, that is in the station premises, if it is accident is happened, data logger also to be collected from the station data logger. Okay, it will be collected. Suppose some CCTV footage, if anything is there, the particular station like Bangalore or Secunderabad or this one and all, CCTV footage also, if it is available, they will collect. That means this and all information, whoever gives the information, they will take this one. And once the joint readings are recorded on a sheet of paper or a video or anything, it is to be signed by these supervisors. Then only the document is valid. If it is not signed, okay, that document is not valid. For example, say you are a CNW person or a loco person, you are only signed and bringing the readings, so that is not valid. That is why joint readings means, so minimum 2 to 3 supervisors has to sign on that. Yes, so we have seen, okay, the measurement gauge 1680 is there, okay, or super elevation, this much is there. So who has to sign? Minimum 2 to 3, minimum they have to sign. Then only the document will be valid. Suppose you are only measured, you are only signing, means the document is not at all valid. Please remember, the document is not valid if there is no signatures at all. But videos are valid. Videos, if you are taken 1 person or 2 persons and all, no problem. That will be, can be given to the inquiry committee, no issue. Okay. So joint readings plays a vital role in the case of an accident. Now, joint readings means the set of readings on the track. Say, for example, gauge is how much, cross level, how much, degree of a curve, how much. Okay. So like this, so many items based on the location of the accident or where the derailment is happened on points and crossings. So then joint readings will change. Okay. So joint readings are not common in all places. Suppose say on the straight track derailment is happened, joint readings are different. On a curved track derailment happens, joint readings are different. On points and crossings, the accident is happened, the joint readings are different on the track. That is why, so I'm keep on telling you, joint readings are different based on the location. Okay, not the same. Okay, it is changes place to place. That is why minimum every supervisor must understand joint readings on straight track, how to take it, joint readings on a curved track, how to take it, joint readings on points and crossing, how to take it. These three minimum every supervisor must know. Okay. So that is why whenever when I was working in IRIDM, so I used to talk about 1 day class on straight, 1 day class on curve, 1 day class on points and crossing. Separately, I'm taking joint readings. Okay, right. So in the joint readings, one more thing is very, very important is the sketch of the accident site. Sketch of the accident site is also very, 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 very important. Sketch if you are doing beautifully, okay, and it is signed by all the persons, that also gives you more information. Here, I will show you the one sketch that is given by Railway Board. Just wait a minute. Are able to see this sketch, all of you? This sketch will give you lot of information. So every supervisor must practice the sketch like this. This is the ideal sketch, I can say. So in my opinion, this is given by Railway Board only. The same sketches you also can make, okay, based on your area. Suppose you are working South Central Railway, so you take some 2 stations of your South Central Railway. So then you can make this type of sketch. So this sketch is very, very important. Here, what is the beauty of this sketch? Lot of information is given. And remember, on this sketch also same. All the supervisors like SSC CNW, similarly Loco Inspector, SSC Permanent Way, all those persons also has to sign on this sketch. This is called a joint sketch. Okay. So generally this will be made by, normally to be made by the SSC Permanent Way or JE Permanent Way, because they used to draw so many sketches. So this diagram also is the responsibility of this, but the signing is the responsibility of the mechanical supervisors. So that is why you must understand what he is drawing on this. Okay. It is a 3-layer sketch. You can see here, there are 3 layers. What is the information they are giving? Just understand. So this is 1 layer. This is the 2nd layer. This is the 3rd layer. That means 3-layer sketch, this is called. Okay. So we'll come to first layer. You have to understand. This is the first layer. This is the first layer. This is the first layer. Okay. This is the first layer of the sketch. So whenever you are drawn one sketch, where the accident is happened, you have to write. For example, say the train is moving, say one from here to here. Say here it is Kakapur, it is written. Here you can see Kakapur. Here it is written Tolegaon. That means 2 stations. For example, say Gutti to some other place. What is the, that side, what is happened? That one. For example, SBC to, okay, say Nayandahalli, NHY. Like this, you have to write it. That means where, in what block section it is happened, you have to show. That is, this is the sketch. Here Kakapur, here Tolegaon. That you have to write it one thing. Okay. So that means always this is to be written. Then one more information you have to understand, where the derailment is happened. So that particular kilometer number. Okay. Here you can see the kilometer number or chainage is very important. That means here kilometer number 92 bar 1.2. Something he has written. Okay. So kilometer number it has to come. Okay. That is second. The third one is here, one LC is there, level crossing gate, okay, B class gate, okay, here, one level crossing, here it is shown here. One bridge also here, in girder bridge number 86 at kilometer number this, okay. Our people, simply they will draw the diagram that is of no use diagrams only, our SSCs, our loco inspectors and all they will draw. So that is of no use diagram. But the diagram must be like this. This is given by, circulated by railway board, not me. Okay. So in this, you have to show if any one gutter bridge is there, you have to show this is the gutter bridge. Okay. That gutter bridge of span, how much is length is there? One span of 6.1 meters. Gutter bridge number 86. Kilometer number 102 bar 11 to 12 like this. So that means main idea is from where the accident started, where this is end. That one you have to show. Okay. That is one. The next thing you have to understand is here this is a coaching train. If it is coaching train, okay, all the coaches may derail or all the coaches may not derail. For example, if you see here, this coach is not derailed, this coach is not derailed, third coach not derailed, fourth coach not derailed, fifth coach not derailed. That means these first 5 coaches not derailed. Okay. The next coach derailed. Next coach not derailed. Okay. So next coach, it is what happened? This is capsized. Okay. So it is in the air. So like this, whatever the effect is there, so that also you have to show. Okay. Then here he has shown the direction of train. Train kahan se kaha ja raha. So that means it is moving from Tolegaon to Kakapur. Okay. That also it has to show. That means your area. Not what I am telling in this diagram, Tolegaon to Kakapur is there. You have to write like this. So you have to write where that accident is happened. Okay, for example, the Gutti to whatever the next station or some station to some station you have to mention. Okay, so like that you have to clearly mention. Okay, what are the non-derailed trains, non-derailed coaches, like that. If it is wagons, wagons. Okay, like this you have to show. Okay, 5 coaches not derailed, then derailed. So then another 5 coaches not derailed. Okay, like this. So then engine number. Here engine number WDM2 1001. Some number he has given. Okay, don't think that 3-4 digit number is not there. That is for only for meter gauge and narrow gauge only 4 digit number. Nowadays we are using only 13270 like the 5 digit number. Okay, so here that loco where it is there, last coach where it is there. So how many coaches derailed, how many coaches not derailed. So those things and all lot of information he has given. Then the length. Okay, from where some reference, always you must see some reference. Okay, so here some parts are fallen. Say for example, drawbar is fallen, CBC is fallen, some axle box is fallen. So that and also he is showing some drawbar here, broken spring here, some axle box here. So something like this, if it is fallen, if you write it, okay. Suppose you can also write not only axle box, drawbar, only coaches only he is showing. So why not some rail is laid here, okay. Something is bent here, like that also you can write it. Okay, don't always think only coach is having a problem or a wagon is a problem, others are not problem, like that and all. Okay, don't say like that. Okay, here axle box fallen, drawbar fallen, some broken springs fallen. So like this it is given. Okay. Then the direction of travel it is given. So here some point it has shown. M means here in the idea point of mount. Point of mount. So here point of mount he has shown. Okay. So point of mount where it is there, that also he has shown. Okay. Like this. Of this, how many wagons derail, how many coaches derail, how many this one, like this. Suppose some caution order is there. For that, some termination for passenger board, termination for goods board, like this also it will be there. That also you locate. Agenda. So now, the information mentioned on the first layer, it is clear to you? Information mentioned on the first layer. Okay, this is the first layer. Okay, so this first layer, you can mention the engine number, station number, kilometer number, bridges number. Here also say, after the engine there is one more girder bridge. See, you can see 2 into 12.2 meters. That means, so here one span, another span, So this is the, okay, one pillar, another pillar, another pillar. This is called a two-span bridge. So this is called one span, this is called another span. This span is of 12.2 meter, this span is of 12.2 meter. Okay, like this, two span. GB means gutter bridge, number 85. Kilometer location 90/10 to 11. Okay, so like this information he has to given in the first layer. Okay, you take one drawing a sheet and draw it. First rough sheet you draw, after that you make it on this, and this will be a good information it will give you. So not only the broken pieces, you can track pieces also you can show. Okay, the curved board is there. Okay, point of termination point board is there. Like this also you can give. So much other data also, if you want, you can put. Right. So first layer is over. Now come to the second layer. Second layer, he has given train number 450 up. Then date of accident, some 15 to 1981. Time of accident, 1.01 hours, night 1 o'clock. Okay, because railways and all, we use 0 to 24 hours time. So that way you have to write it. And the kilometer number from where to where it is happened. 91/0 to 91/7. That means this point to this point. Okay, you have to tell about this kilometer number like this. So that means train number it came, date of accident it came, then time of accident it came, then kilometer number also it came. Is it clear to you or not? It's clear. Okay, right. The next is here, if you see second line, so he is telling that this is the left rail, declaring this is the left rail like this. Okay, this is the right rail. I told you to the right, okay, left and rail based on the, okay, train movement. Say train is moving like this. Here also shown, okay, direction of train. So this will be left, this is the right. Okay, same thing he has mentioned. Left rail, right rail. That is one. So then he has shown where the point, okay, important points you can see. Say here he has shown, I'll mark it. This is the M. M means the point of mount. D means point of drop. M, D are the meant for point of mount and point of drop. This he has shown. So from here, how many meters it is there, rail joint and all, if anything is there, that also he is showing 32 meters away. One rail joint is there. So he has shown one rail joint here. Okay. And T point. Okay. Termination point or any other thing is there, that you can mention all these things. So here also he has mentioned M means point of mount, D means point of drop. Then he has shown some dotted marks. This is very important. These dotted marks are called wheel marks on the sleeper. Sleeper ke upar, where, say for example, this is the track. Over this, these are the sleepers. Okay. So once it is derailed, what will happen? It will create some marks. Okay. Like this it will be. So those marks also he has shown clearly. Path. This is also called a path of derailment. Okay. So path of derailment also he has shown clearly. Okay. So this is very important. Here where the important derailment spot is there, that only he is highlighting. Okay. These things. Now, not only this, you can give any much of information. Okay. No need of exactly this information. You can give more information also. No issue on that. The next is, he wanted to show that derailment is happened curve. So here curve number 10. Any curve if it is mentioned, curve will be having two parameters always. One is called degree of a curve. Then another is called radius of a curve. Radius of a curve. Length of a curve. These things are. So degree of a curve is 3 degrees. Radius of a curve is 50. Tan transition 1%. So sound is coming, ma. Hello. Okay. So now this is the curve. Whenever the accident is happened on a curve, this is accident happened in a curve only. Please see. Okay, how do you know? Here he has shown a curve number, degree of a curve, radius of a curve, cant of a curve, then transition length of a curve. So these things will be mentioned on a curve board. So curve, any curve will be having one peculiar number. So that also you have to mention. Clear to you up to this? Is it clear? Is it clear?
Yes, sir. Clear.
Okay, right. The next is this one, because we are discussing more on the track. That what is the type of track they use here? It is mentioned. Track is he has mentioned a 90R 3-rail SWR track. Okay, what is this 90R track? So 90 earlier I told you, nowadays we are using 52 kg rail, 60 kg rail, then 68 kg or 60 kg modified. Like this, I am telling this. This 90R and all only used 75R, 90R rails and all. It was used only in meter gauge and some of the broad gauge. Nowadays 90R rails are not there. In our Indian railway track, nowadays, majority 99% of the cases, 90R rails are not there. Sir, what is there? Either 52 kg or 60 kg or 68 kg. This only will be there. So here you have to mention about whether it is a 52 kg rail or a 60 kg rail or 60 kg modified, whatever it is there, that only you have to mention. There is no 90R rails in broad gauge. Clear? Then next. Next is 3-rail SWR. So what is this 3-rail SWR? 3-rail SWR means say one rail length in the olden days or even nowadays also, one rail length will be 13 meter. 13 meters only will be there. Standard rail length of a rail is 13 meters. One more rail, 13 meters. One more rail, 13 meters. Like that only it was there. Up to last 10 years and all. So the SAIL only is supplying the rails for us. So the Steel Authority of Limited, India Limited, it is supplying the rails for us. So that is supplying 13 meter rails. Nowadays we are getting 26 meter rails, 39 meter rails and all. Earlier we are not getting. So now, what is this 3-rail SWR means? Now, like our workshops of a wagon workshop, then loco workshop, coach workshop and all like this, how it was there. For them also, the rail workshops were there. In the rail workshops, what will they do? This rail and this rail will be welded together here. Here, it is welded. So, with the help of a flash butt welding. Flash butt welding, they are welding. So now 13 plus 13, if it is welded, so 26 meters it is there. Another one it is welded, it will be 39 meters. So if 3 rails are welded in the workshop, that rail length will be now 39 meters. Okay, this will appear like this is called a 39 meter one rail. Then another 39 meter one rail. If they are used with the help of this fish plated joint, this type of track structure, we call it as a 3-rail SWR. Is it clear? 3-rail SWR? SWR means short welded rails. There are 3 types of railway track in our Indian railways. Short welded rails, okay, long welded rails, continuous welded rails. There are 3 tracks are there. Nowadays, this is the common. This and all gone. Okay, this is the future. So now we are using this LWR track, long welded rail. What is this and all? This one more half an hour class is there. Okay. Short welded rail understood or not? Short welded rails and all except in the yards, main lines it is not there nowadays. That is why I am telling my SSCs and JEs, you have to understand about what is LWR track. So if you want to know the track parameters and all, you must understand first LWR track. Okay. So LWR track means long welded railway track, that only is available. For example, say between Bangalore to Mysore, Bangalore to say Arsikere, Bangalore to Chennai and all. We are not using this SWR track. We are using only LWR track. LWR track only available. Okay. So you have to write it here, LWR track, say 60 kg. So LWR track, like that we have to write. Next. CST9. Okay. Earlier, old type of sleepers is CST9 sleepers. CST means, okay, concrete, okay, steel sleepers. That means this is the CST9 sleepers they are using earlier. This also not there, outdated. So now what type of sleepers we are using? PSC sleepers. That means pre-stressed concrete sleepers. Okay. In this case, we will get a PSC sleepers. This case. So that is why you have to modify this diagram to the present day technology, present day advancement. You have to modify this diagram. So this diagram, why they have given the civil engineers, I do not know. Okay, they have to give the present day diagram. Okay, wantedly they have given or I don't know. So I wanted to modify this diagram with the help of the present day technology diagram they have to give. The next is called density, sleeper density. This is also very, very important. M+7 sleeper density. So what is this M+7 density? I will explain to you. Say this is the track. So under this track, this is one sleeper. This is one sleeper. This is one more sleeper. This is one more sleeper. The center of this sleeper to this center of sleeper, if you are measuring, so the distance, it is called sleeper to sleeper distance. Okay, or also known as sleeper distance. So the sleeper distance generally 60 centimeters, 50 centimeters, like that only it will be there. Okay, suppose 60 centimeters is there, then in the M+7 forms are how to convert. It's very simple, very simple. Say here, what is the first, you understand what is the M+7? M means the standard rail length, okay, 13 meters plus 7, so that is equal to 20. So what is this 20? 20 sleepers. So 20 sleepers, where they placed on 13 meters rail length. So 13 divided by 20 into 100, it will give you the sleeper. Okay, anybody is having calculators with you? Okay, you calculate this. So 13 divided by 20, that will give you 65. Okay, is clear? Are you following my lecture? Okay, so 65 centimeter means the center of the sleeper to the center of the sleeper, this distance is nothing but 65 centimeter. If it is there, so that type of track structure, we'll call it as a M+7 sleeper density. Okay, these meanings our supervisors must understand. SSCs, JEs, they must understand what is M+7, M+8, M+4, these things. So remember, for a derailment not to happen means the distance is very closer. For example, say if he is applied every 60 centimeters only, the gap is there. So that means track is strong. If he is maintaining one sleeper to another sleeper 75 centimeters distance or 1 meter distance and all, track is weak. Why? Because whenever the wheel it is moving over here to here, if more the gap is there, more okay, curvature it will form. Okay, so this is called a concave structure and all, it will formation. If more gap is there, so more formation it will take place. That is why more the gap, dangerous to the track. Less the gap, okay, that is good for the track. Is clear? What is M+7 clear to you or not? Okay, right. The next is, here you have to mention about, then in this, I forget to tell you one more point. Nowadays, our civil engineers are using the word, sir, my sleeper density is 1560 sleeper, sir, 1660 sleeper, sir. Like that also they are using word. There are two ways of representing the density of a sleepers. One is this method, another is this method, M+7 method or M+9 method, and all they are using. Okay. So here M+7, M+9 means I explained M place you replace with 13, 13 plus 7, 20, 13 by 20 you have to do, you will be getting this M+7. Okay. But if he is telling in 1560 sleeper density, 1660 sleeper density, what the difference? This also I can explain. 1560 sleepers per kilometer, you have to understand, per kilometer. So kilometer means 1000 meters. So if you want to get the distance between one sleeper to another sleeper, 1000 divided by 1660 into 100 you put it. So you will be getting the value for this, that is 1000 upon 1660 equal to into 100. Okay. So 60 centimeters. Suppose if it is 60 centimeters, sleeper density, that will be called as 1660 sleeper. Railway board, it is insisting on all our track people, you follow 1660 sleepers on 60 kg rails. So 60 kg rail where you are using, you have to follow 1660 sleepers. Okay. Whenever you are using 52 kg, you follow this method. So that is 1000 upon 1560 into 100. That is the sleeper density in the case of, this is in the case of 52 kg rails. This is in the case of 60 kg rails. So if they say this word, you calculate this way. If they say this word, you calculate this way. So sleeper density calculation clear? Got it. Okay. Right. So now the next is they are also writing the one more word called curve gradient is 1 in 150. 1 in 150 gradient. Okay. So that is 1 in 150. 1 in 150. What does it mean? Means it is nothing but a slope of a track. So 1 in 150. So that is tan theta is equal to 1 upon 150. So that implies theta is equal to tan inverse, okay, 1 in 150. If you do it this one, you will be getting what is the slope of that, okay, or degree of that, you will be getting this. So this is in, okay, making this one 1 in 150. So this will be useful 1 in 150, 1 in 50, 1 in 100 and all. So gradient. Generally 1 in 50, 1 in 37 and all. So for example, Dudhsagar in the say for in the Hubli division, 1 in 37 gradient. So 1 in 37 gradient is a dangerous gradient. So there to make the brake power good, so they have to attach 2 engines in the front, 2 engines in the rear. Okay. So in our section we have one gradient called 1 in 150, 1 in 50, that is between Sakleshpur to Subramanya Road. 1 in 50 gradient. 1 in 50. These are all. If this number is lesser and lesser, the danger is the track and more prone for the derailments. That is why the trains has to move very slowly. If gradient is 1 in 37, 1 in 30, 1 in 60, like that it is there, it is nothing but a dangerous track. Okay. That means brake power control is very, very, very important. If you are not giving a 100% BPC, there is a chance of derailment. Yesterday what happened? Seal ulta agida. Okay. Here photo mila. This gradient, if the number is less, the track is dangerous. If the number is higher, the track is smooth. So 1 in say 150, 200, 300 and all normal track only. Normal track will be having 150, 200, 300 and all normal track. Right. The next is here, you have to understand so many other things also. Curve is 3-degree transition. 3-degree transition curve. So for this also separately I have to take a class. Anyway, brief only I will explain. 3 degree. Actually railways, our locomotives and coaches will negotiate easily 8 degree. Highest degree permitted in the Indian railway tracks is 8 degree. If the degree is 9 degree, 10 degree and all, that means it is the dangerous curve. Suppose a curve is like this, curve is like this, curve is like this, curve is like this. So this curve is a dangerous curve. Okay, this is the dangerous curve. This is less dangerous. This is still less dangerous. This is less dangerous. That means, say, this degree will be, say, 3 degree for example. This will be 4 degree. This will be 6 degree. This will be 3, okay, 6. That means degree will increase. Say this is the 8 degree. So degree is lesser and 0 degree means straight. Remember, this is the 0 degree. 0 degree track means straight track or horizontal track. This is called 0 degree. Clear? Okay. So 0 degree track means straight. Then 1 degree. Okay. Little, okay, curve. 2 degree. Okay. More curve. 4 degree. Still more curve. 5 degree. Still more curve. That means, which is the dangerous curve? Can you tell me? 8 degree is the highest sharp curve. This is called sharp. Why it is sharp? Actually, this is one more class I have to explain. Okay. So now time being, please remember, if the degree is higher and higher, the accident prone is higher. Okay. Degree is lesser and lesser, the accident prone is lesser. That means 0 degree means a straight track. So normally no derailments will take place. Okay. 1 degree also good only. 2 degree also good only. 3 degree also good only. So more than 8 degree, 9 degree, 10 degree and all. So our locomotives or coaches are more prone for derailment. Okay. So that is why already Railway Board has given a circular that do not make any degree of a curve in Indian Railways more than 8 degree. So 8 degree is the highest degree. So whenever there is no other route to make it lower degree, then railway is permitting the 8 degree curves on Indian track only on this particular condition. For example, say this is the 8 degree curve. Okay. So in any curve, 2 rails will be there. This is called outer rail. This is called inner rail. Okay. Inner rail, outer rail. So whenever this type of curve it is there of 8 degree, okay, and above it is there, it is mandatory to provide chuck rails in the inner area. In this area, they have to provide other than this rail, one more rail that is called chuck rail. So chuck rail is a compulsory. Okay. Chuck rail, when it is a compulsory or mandatory, 8 degree and above if it is provided in unavoidable circumstances, then chuck rails is a compulsory. Sir, chuck rail is provided, how much gap they have to maintain? The between this rail to this rail, the gap minimum must be 44 and above. Sir, why this 44 and all? Because this 44, it is derived based on your flange thickness 16 mm. Then play 19 mm play plus 16 mm flange thickness if you take it. So 28.5 minus 16 mm. So that will be 12.5 one side, another 12.5 one side, flange thickness reduced. So totally 25. If we add 25 here, this will be 44. So based on this only, they have calculating this, okay, chuck rail clearance. So chuck rail clearance permitted is 44 to 47 mm. It is permitted. So many derailments are happened in the curve. I have seen some 4 to 5 derailment. So in the chuck rail, if it is filled with say some ballast, these things, and also it may leads to derailment. Or chuck rail cut also leads to derailment. So actually here, how the derailment will take place means, say whenever the 8 degree curve is there, normally loco pilots are advised to go at a normal speed. That means a very restricted speed. What is the restricted speed? For example, say 30 kilometers per hour they have to go, for example. So why 30 degrees is designed? Because here the forces that are there, the radial forces, if it is not maintained 30 kmph per hour, if it is maintained some 90 kmph per hour, what will happen? The radial forces will predominate and will go like this. Derailment will take place like this, and it may leads to the bigger accidents. So that is why for this one separate class I need actually. Okay, what is a curve? What is the degree of a curve? What is the radius of a curve? So why these things and all maintained? So for this 1 hour to 2 hours it will take place. So that is not easy to understand. So this we'll discuss later. First you have to understand only the peripheral details. Peripheral details means what is the degree, which degree is dangerous, which degree is not dangerous. That only you have to understand. Say this is the curve, this is the outer rail, this is the inner rail. Inner rail, outer rail. So in outer rail, inner rail, where the check rail will be provided? Here. When it is mandatory, compulsory, if the curve is more than 8 degree. 8 degrees say more, 8.1 degree is there, compulsory. 8.5 degree is there, compulsory. 8.6 degrees there, it is a compulsory. So therefore, check rail is a compulsory, and also in good way it should not be broken. Okay, good way it must be. So then only this is permitted curve. Otherwise, it is not a permitted curve. So then one more point I wanted to tell you is, sir, today they have made a 8 degree curve and trains are allowed. Sir, will it be permanent? 8 degree will be continuously, it is available. Say, for example, say on February 2nd, February 2, 2023, the civil engineers will made one 8 degree curve. Okay. Then the next year, say on 1st, 2nd, 2024, so it will be 8 degree? No. So because of our trains, what will happen? The curve may alter. 8 degree will become into 7 degree or 6 degree, also possible, or it may become into 8.5 degree or 9 degree, okay, or 10 degree, also possible. That means this curve may likely to alter. Why it will alter? Because of the various forces that is occurring. That is also called as centrifugal forces. So that's what I told you, one class is required for this. So due to the centrifugal forces, what will happen? 8 degree may become into 8.5 degree, 9 degree, 10 degree, and all it may go. It may go. Not, I am not telling that 100% it will go. It may likely to go. Okay. Similarly, it may reduce also into 7 degree or 6 degree also. So that is why whenever an accident takes place on a curved track, your one more idea is you have to measure the one more thing is called Versailles. Versailles is a compulsory to be measured whenever derailment takes place on a curved track. Whenever on a straight track, Versailles will be 0. Okay. On a curved track only, Versailles will be there. Okay. On a 1 degree curve, the Versailles will be 28. On 2 degree curve, Versailles will be 56. Like that, based on the degree of the curve, the Versailles also will changes. So how to measure the Versailles and all? Okay. In the same curved track only, we have to explain. This is a very, very, very important topic. The curved, that means accidents on a curved track. Okay. What is a Versailles? Because when I joined in the railways, so my seniors are telling, sir, you have to measure Versailles. First, they have not explained what is a Versailles and all. But how to measure and all they explained, but not explained what is Versailles and all. Okay. So how to measure is very simple. Versailles will be measured on the outer, okay, rail. On this you have to measure. Say first here point of, mount it is there. So here you take a 20 meters cord. So here this distance you have to measure. Okay. This is called some Versailles 1, Versailles 2, Versailles 3, Versailles 4. Like this you have to take a V1, V2, V3, V4 like that various values up to 300 meters piche, 45 meters ahead, all these things places you have to see. Based on the Versailles, I can calculate what is the degree of that particular car. So this degree, what after calculation and the degree on the board matches, then PWI will be safe. Otherwise, say the board is showing 8 degree, my Versailles calculation and all showing say 10 degree. So that means the alteration has happened to 2 degree more. So that means the derailment proneness has been drastically increased. So therefore, the reason for this derailment will be automatically on the curve not maintained to 8 degree, therefore the derailment took place. Like that only I can prove it. That is why the curved track degree measurement, okay, or degree finding, or radius finding, and versine measurement, these are all very, very, very important. Is it clear to you? Okay, this is a separate subject. Okay. Anybody wanted to say anything? Okay, right. Because it is not easy. Okay. Some of you are known all these things, but those who are from basics, for them it is required. So that is the main idea for me. Right. Now, ballast cushion. Ballast cushion is, here it is mentioned 150 mm clean, below sleeper 250 mm total. So, what is ballast cushion? Say, this is the track. Under the track, sleepers, it will be there. Directly, it will not be there. Okay. So, ballast cushion, you have to measure from the sleepers are below. Say, this is the rail. This is the rail. Okay. So, under the sleeper, so they will put some ballast. Okay. So, this distance is the ballast cushion. So, this also the engineering department will confuse you. So, normally the top ballast will be there, free stones will be there. The bottom based on the soil. Say this is the soil. So, suppose soil is a black cotton soil or red soil or a sand soil and all. So, what will happen? Black cotton soil means this will stick to soil. This will be stick to soil. This will be stick to soil, and some soil here also it will be there. Some soil it will be there. So, that type of soiled one should not be counted. So, that is why here it is written ballast 150 mm clean ballast. So, that means the top it is called a clean ballast. The bottom it is called a caked ballast. Clean ballast, caked ballast. Clean ballast means the ballast which is easily separable. One stone separately if you are able to separate, that is called as a clean ballast. Clean ballast is good for the track. Caked ballast means it is almost forming into the strong nature. So that is why caked ballast is dangerous. This is called a caked ballast. Caked ballast is not permitted. So that is why you have to measure how much is the thickness of the clean ballast, then caked ballast, then total ballast, like that. Okay. So that is measured is 150 mm clean, then 250 mm total. That means 250 minus 100, the 100 mm is the caked ballast. Is clear? 150 mm clean, total 250 mm total, it is clear to you? Okay, right. Then on that particular time, that accident time, rainfall is there or not? Okay? Or nightfall is there or not? Or daytime it is happened. So all these things also, rainfall nil during this one, and 4 days preceding, that means say today it is accident. So 4 days before also not fallen. So why this one? Because this influences will be there, this will be drained away. If it is rainfall, it is there, this ballast and all will staggers, and thereby there is a chance of this. Okay. So one accident is happened here, Guntur to say Secunderabad, this Nadipudi line. So one day what happened, the entire one the track is washed away with the help of a filling of the one pond. Pond is filled with water and track is washed away. Okay. Due to that, almost 100 to 250 members in Delta Express. So going from say Repalle to Secunderabad, so almost 200 members died. Okay. In that, track is washed away. That means this ballast and all fully washed away. Such type of things also will happen. That is why rainfall is also important if it is there. Then formation is stable. So formation means below this soil, that soil that is there, it is the sandy soil, that and all you have to explain, or normally you can write it stable or unstable you can write. That means if it is moving due to the draining of the this one, if it is there, no rains means normally stable. If rain is there only, unstable and all you can write. Because in one of my accident presence, what happened, soil is sinking like this. Okay, whenever we are putting a say our crane hooks and all, so that is going down, proppings and all going down. So that implies that the soil is not stable. Okay, it is unstable soil. So like that also it will be there. So this data also you have to explain in the case of a diagram. The next, the third layer, one more information is given. That is, so how many coaches derailed, how many coaches not derailed. Say some coach number, this is derailed. So derailed also, whether all 4 axles derailed or 2 axles derailed or 3 axles derailed, that also you can mention. This is derailed, second coach derailed, and this is capsized. So this is also capsized, this is derailed, this is derailed. So like that you can write it, what are the derailed coaches, what are the capsized coaches, or what are the derailed wagons or capsized wagons and all, you have to mention in the third layer. So this diagram will give you lot of information. Is it correct or not? Lot of information are given or not? So this type of diagram, you have to make it one rough diagram in our area with present day technology. Okay, because in this wantedly they have given some old rails, old data is given. You have to mention with the new technology. You have to remain it. That means this LWR track, this rail, these sleepers. Okay, these things and all you have to change it. Right. Are you feeling bored or interesting? Huh? Okay, very good. From IRIDM, anybody following?
Yes, sir.
Okay, Kumarvelu, very good. Because time given to me is up to 1:30, I will take up to another 20-30 minutes. I will take. Okay, then I will wind up. Right. So the diagram making is very important. You have to mention in the 3-layer way, and each and every point is very important for the accident investigation. Now I will come back to our this one. Right. So we are continuing the joint readings. That is called a joint diagram. We have made it. So that is ready. So this only I told you sketch of the site of accident. That only we have discussed. Say the sketch of accident. After that, you must also know that say this is the say sketch we have mentioned in this point of mount, also known as POM. We are writing. That POM area, we have to put it a 0, 0. This is the 0, 0. So now, as I said, roughly, this side you have to mention, say this is the direction of the train. Okay, like this train is moving, that time accident is happened. So this portion it is called rear of the, okay, point of mount. This will be 300 meters. This is the head of the point of mount, 45 meters. Okay, sir, in this 300 meters, what are the things to be measured and how it will be measured? Okay, that is also very important. Out of 300, first 0 to 9 meters. This is the 0, 0. 0, 0 is the reference from 0 to 9 meters. Okay, so 0 to 9 meters length, if you go, as I said to you, 60 centimeters is the one sleeper to another sleeper. There will be around some 13 sleepers will come. Okay, or 12 sleepers will come, for example. So every sleeper area you have to measure gauge. I am talking about straight track. Okay, you have to measure gauge. You have to measure. So gauge means I told you standard gauge is 1676. If it is more, it is called a slack gauge. If it is less, tight gauge. Then you have to measure cross level. You have to measure cross level. Okay. Say, for example, I will take this one. See here in this. Say this is the track, straight track I am taking. This is the point of mount. This will be called as 0. 0. This side is 300, I told you. This side 300. This side is 45. This is meters, not millimeters. This is meters. So from this reference, say this is one sleeper, second sleeper, third sleeper, fourth, fifth, like this. 12 to 13 sleepers will come. Okay, this will come. Here there is no space. That is why I am leaving here. So 9 meters. Okay, so this 9 meter distance. Okay, what we are supposed to do here? What is the gauge value? Even 0, 0 also. 0, 0 also you have to measure. This is a slave. Okay, 1, 2, 3, 4. Even 0 also, if you take it 0, minus 1, minus 2, minus 3, minus 4, minus 5, like this. So remember, minus when you are writing, you are going towards this side. Okay, this is also called as station number. Okay, so that means 0 means on where point of mount is there. So minus 1 means first sleeper, minus 2 means second sleeper, minus 3 means third sleeper. Like this you are going. Okay, so here how much is the gauge? So here gauge is, for example, say you got a 1680. So 80 means a 4 mm. So here you have to write it plus 4. Okay, plus 8, plus 10. So like this, whatever you are getting, that one. Say minus 6, minus 8. So these are all gauge. Whenever plus if you are showing, that is called slack. Minus you are saying tight. Okay, like this you have to write it, gauge. Okay, so up to 9 meters. Then 9 to 90 meters. 9 to 90 meters. So that means this 81 meters, I mean to say. So in this 81 meters, what you are supposed to do is, every 3 meters, you have to take the reading. That means already 9 meters covered. So 9 plus 3, 12 meters area, you take a gauge and a cross level. Then 12 plus 3, 15 meters area, you take a gauge and cross level. So 15 plus 3, 18 meter area, gauge and cross level. 21 meter area, gauge and cross level. Like that you keep on, okay, taking the readings on this side. Okay, so up to 81. 81 to 300 meters, you have to only observe the things, track observations, not the readings. Is clear? So now the gauge is to be measured up to 90 meters from the 0 station to this 90 meters. This one is 90 meters. This is the 90 meters. Then 90 to 300 meters only observations. So gauge you have to measure, cross level. First you have to make you to understand what is the cross level. So cross level is very simple. Say I told you one side rail will be there, another side also rail will be there. Okay. So this, if I am calling it as left rail, this is the right rail. So if you make one horizontal line, okay, between these two lines, so the distance between these two difference, vertical difference, this is called as cross level. Cross level. Okay. So civil engineers, what will they do? SSC permanent way and all. They will write X, okay, L. Okay. XL is nothing but cross level. Okay. There is shortest form, because our mechanical engineers and all, our electrical engineers, CKT, they will use na circuit. Okay. For cross level civil engineers, they use XL. That is called cross level, that word. So this and all, if you are habituated to attending many derailments, these wordings and all will be known to you. Okay, cross level. So cross level, say for example at 0 station, both are in the same level means 0 or normal level. So here 10 mm. So 10 mm means between one rail to another rail. For example, LR, now right rail is more left than this. So here what we are supposed to do, say for example, LL left low, RL right low. So LL, here left side is lower than the right rail by 10 mm. So 10 LL you have to put it. 10 LL. So 10 LL, 20 LL, okay, or 25 LL. LL means left rail low. RL means right rail low. Okay, like this you have to understand and keep on taking this cross level. Similarly, I told you the fasteners. Fasteners means pandroll clips, liners, sleepers, or any bend. So those observations also you have to take it as remarks column. you have to take it. So gauge, cross level, remarks in the straight track. If it is a curved track and all, then you have to measure the versine readings also. If it is a curved track. If it is not a curved track, so you need not measure versine. So if it is a points and crossings, the parameters will be still different. Okay. So there we will get it, the tongue rail, stalk rail, okay, where the joint is there. So those things and all different. Okay. That is why the position of the derailment to derailment, the readings will changes. Okay. Any doubts for anybody?